So in today's video, we're going to continue talking about proportional relationships. So remember that those are relations of x's and y's where every y over x are equal to one another. And that becomes the slope in our equation. So we have y equals 3x here, where 3 would be the slope. Okay, so we're going to take a look at how we can figure out whether a point or an ordered pair is on the actual line of the equation and if it will show up on the graph. Okay, so we're going to start by using the equation given to evaluate using the point x and y. We'll simplify the equation, and if both sides are equal, then the point is on the line. So we'll complete the table with the correct values for x and y if they are not already there. Okay, so in our first example, like we said, we have y equals 3x. So remember that that means that 3 is multiplying x. And in our ordered pairs, we always see x and then y. So in this first example, I'm going to replace in this formula y equals 3x. I'm going to take my y and write 9. 3 is part of the formula, and then I'm going to write 3 where x was. So I'm getting that because y in here was 9, and my x value in the point was 3. So I replaced x with 3. Okay, so that's all I've done is I just plugged in those numbers where the letters were. Now I'm going to actually simplify this. So I just have 9 on this side of the equal sign. And if I look at this, 3 times 3 is 9, right? So I got the right value for that I was expecting. It's equal. So that means that if I have an x of 3, my y value should be 9. Okay, so we'll repeat that process with the other two. My same rule is still here. So I'm going to say y, which is 18, should equal 3, which is part of my rule, times my x value of 6. 18 is equal to, and when I do 3 times 6, that actually gets me 18. I'm not just writing it because I see 18. I know that 3 times 6 is 18. Once I've verified that, I see that they're equal to what I wanted. So if I plug in 6 for this rule, then my output of y is 18. So in this last one, we have -1, 3 as our point. So x is -1 when y is 3. So we're going to see if this fits in the equation. So I have y equals, and that's going to be my 3. Then I have my rule 3 times my x value, and this time my x value is -1. So I'm going to go ahead and multiply. I have 3 on the left side of the equation, and then 3 times -1 is -3. Now notice how I have 3 equals -3. We know that that is not true. Those are different numbers. So this means that this point is not on the line, okay? But we do know that the answer we got should be on the line, right? So in our table over here, when x is -1, we're going to say that y is actually -3. To show you what that looks like on the graph, if we zoom out here, I have one over on the side. If I plot the 3 points that I now have found in my table, -1, -3 is over here. 3, 9 would be somewhere off my graph, right? I can't really see that. And then 6, 18 would be off my graph. So I can't really quite see it. Just for the sake of this graph, I'm going to try one other x value just to show you what I'm talking about. So let's plug in x of 2. If I plug in a 2 in this equation, y equals 3 times 2, which is 6. So that means I have another point at 2, 6, which does fit on this graph. So if I take my pen and I try to connect this, if I do it carefully, and if you had a ruler, right, you would make it nice and exact, this is what my line would look like, right? So those points we talked about, 6, 18, and 3, 9, even though I don't see them on this graph, they would be there. And that point that we said doesn't work, right? Remember we said -1, 3 won't work. If I look over here and go to -1, +3, that's this point. This red point is nowhere near the blue line that I ended up drawing, right? I have all the other points that I tested that would work, right? But this point did not lie on the line. So when we say it's not on the line, that's what we mean. It's not showing up when you plot the points. So you don't have to plot the points to figure it out, but it is a nice way to visualize why that's not working. We're going to continue, so if you understand how to check each point, go ahead and move on to the next one. If not, you can follow along with me and we'll keep going. So in our next example, we have the line y equals 2x. That's what's given to us, okay? So in that, our y value is going to be plugged in, and 2 should be multiplied by whatever x value we had. If x is being multiplied by 2 to make y, then it's true, okay? So let's take y equals 2x. That's our rule. Remember, those are multiplying. My first y value is 14. 2 is part of the rule, times, and my x is 7. 2 times 7 is in fact 14, so this is true. This point would be on the line. So when x is 7, y is 14. On the next example, I have -9, -18. So I start by replacing my y value, which is -18. 2 is part of the rule, times my x value of -9. And I'm going to put that in parentheses just so I don't lose track of the negative sign there, okay? I have -18 equals 2 times -9. Positive times a negative is a negative, and 2 times 9 is 18. So that is also true. So when x was -9, then y is -18. In our last example, we have the point 16, -8. So I replace my y value as -8. It should equal 2 times my x value, which in this case is 16. So I have -8 equals, and 2 times 16 is 32. So unfortunately, this one is not working. This would not be on the line. But we did see what it would be, right? When we plugged in our x of 16, our y value was 32. So over in the table, when x is 16, we actually know y should be 32. So if we had our coordinate plane out, we could plot any of these points and we could find more, right? You can always plug in whatever x you want. So for example, I could plug in a 1, and I know that 2 times 1 is 2. I could plug in -3. If I do that, 2 times -3 is -6, right? That's going to get me all of these points. I could do as many as I wanted. And each time I'm going to get that the x is doubled to make the y. This point did not work because our x actually got smaller when we multiplied it and ended up as -8. So that means that we were not multiplying by 2. Okay? In our last table here, we're going to keep going and check to see which of these points is going to be on the line y equals 1/2 x, meaning x is being multiplied by a half. So as a reminder, when we do this, y equals 1/2 x, 1/2 is being multiplied by x, and x is going to be a whole number or integer here. We have -14, -4, and +6. So when we multiply a fraction times a whole number, remember our fraction can always be made by writing the whole number over 1. So we might need to do that. If we also think about it in this way, then we also can see that this would be the same as 1 times x, which is just x, over 2 times 1, which is just 2. And so multiplying by that half is really the same as dividing by 2. So if it's easier for you to divide by 2, feel free to do that, or just multiply the number by half and you will get the same answer. So we have y equals 1/2 x as our rule this time. We're going to go ahead and fill in our y value of 3. My 1/2 is part of the rule, and then my 6 is the x value, okay? So 3 should equal, and then I do 1/2 times 6. That becomes 6 over 2, which is 6 divided by 2, which makes 3. The other way I like to think of it is I just say half of 6 when I translate that, and half of 6 would be 3. So that's what I got, and that means that when I plug in an x of 6, my y value is 3. On the next example, my x is -4 and my y is 8. So I'm going to replace y with 8. 1/2 comes from my rule, and I multiply by the x value of -4. Again, I'm going to put that in parentheses so I don't lose track. 8 is on the left side of our equation. Half of -4 would be -2. So those are not equal. That means that this is not a point on the line, this point right here, not on our line. but we do know what point will be on the line. When we plugged in -4, we actually got an answer of -2. So that one would be on the line. And in the last example, we plug in our y value of -7 equals 1/2 times our x value of -14. So -7 equals 1/2 of 14 is 7, but a positive times a negative is a negative. So I get -7. That's what I was expecting to get because that was the y value, meaning this point would be on the line and we can fill in our table accurately. In the next part, we're going to be working on how we can graph a line if we're only given 2 points. Okay, so when you see these examples, I'm going to give you some information about what the points are, but you're not going to have all of them. And once you have the 2 points, you're going to be able to find the slope and figure out what the equation is. Okay, so in this example, we have a line passes through the points 1, 4, and -1, -4. So what is the equation of the line? You can fill out the table to help you determine the relationship. So right away, we're already given 2 points. 1, 4 would be at +1 on our x and up 4 on the y. So this is the first point. My second point is at -1, -4, which is down here. Now, I already have 2 points. I could take my ruler and connect them and I would have a line, and I could see where that line is going. That could help me figure out what another point is, just to see where I'm going with that, okay? Or we can try to look for patterns in our table. We already see that we have these 2 points. Think about what we've learned before. If this is proportional, it should go through the origin, and all of the y through x's, or y over x's, should be equal. So if I plug them in, I have 4 as a y value over its x value of 1, and that equals 4. Then I have -4 over -1. And a negative divided by a negative is a positive. So notice how I got the 2 same answers, right? So since those 2 points that are going to make my line are having that same ratio of y over x, that means that I can safely say this is going to be proportional. So remember that that means a couple things. We can write our equation in the form y equals mx. M will come from that ratio that we just found, and we will be able to write the equation that way and find other points. One point that we know is on every proportional relationship graph is 0, 0, or the origin. So we can add that in. And notice how that lines up really nicely with what we've already plotted. So if we were trying to connect these dots, I could see that they're going that way. Now, as we're looking at this, we can try to find one more point, okay? So I already see my graph kind of increasing, and it looks like it's passing through this point 2, 8. But I'm going to confirm that with what I see in my table. If I have an x of 2 and an 8 of y, let me check to make sure that it gets me the same ratio so it's still in that proportion. 8 divided by 2 is 4, so that worked. So our final equation for this will be y equals 4x. You can find any other point on this graph by plugging in another x value and you will get your output of y. If that made sense, go ahead and try number 2. If not, keep following along. In number 2, it says a line passes through the points 8, 4, and 10, 5. So what is the equation of the line? Fill out the table to help you determine the relationship. When I go to the point 8, 4, that's going to be up in quadrant 1. And then I have 10, 5. So 10 would be right after 9 here, right on the edge. And 5, again, right up here. All right? So we already have 2 points. And if I were to connect them, it's kind of hard to see where the whole line would go without being precise. So let's use what we just talked about with testing to see whether this is proportional. We'll know if it goes to the origin or not, and we'll be able to figure out what that slope is. So I have y over x as my ratio that I want to test, 4/8, and this fraction is able to be simplified by 4. We get 1 over 2. So if I check my second one, I have 5/10. Those are both divisible by 5, making this 1/2 as well. So this is proportional. And remember, every proportional relationship has to go through the origin. So there's another point that we could put on our graph. And then I'm going to try to fill in one more point between there. So I'm going to pick another x value that's between 0 and 8 to plug in. Let me go with 4. If I do 4, okay, I'm going to think about where that might go just based on where my line is already kind of being drawn. So if I'm precise with my drawing, 4 should end up around 2, right? So let's check that. We think it's going to be 4, 2. If I plug that in, 2 over 4 simplifies to 1 over 2. And that's what we wanted, right? So our proportional relationship equation is in the form y equals mx, and we just saw that our m is 1/2. So instead of writing m there, I'm going to fill it in as my 1/2. So next time we look at our graphs, we're going to be talking about how we can look at the graph first and then build the table and the equation based on that.